Hello guys. My name is Rada, and I will be your teacher for the software design pattern in Python. Before we start, I want to show you what you will learn in today's video. In this video, we will understand and see an example in Python of the Liskov substitution principle. I will use Python 3.8. So, let us start. The Liskov substitution principle states that objects of superclasses should be replaceable with objects of the subclasses without breaking the program. We will take an example to understand more. A student of mine will help me in this lesson. Student, can you please write a class bird with one method called fly and two other classes eagle and penguin, which inherit from class bird?
Okay, I will start by creating the class bird. This class will just have a method, maybe method info, to give us info about the bird. So here in the super class or the base class, we just raise non-implemented method. So this class can be implemented in the subclasses. Okay, I will just also add the method fly, which just print I am flying. Okay, great. Now we put the first subclass, class eagle, which inherit from the class bird, and here we just implement the method info, like we said earlier. Info, we just write print I am an eagle. Okay, that's all. We will do the same thing with the class penguin. Here, penguin, I am a penguin. Okay, that's it. Now we will test the program. If name equal name. Okay, we will first create an object of the class eagle. Eagle, it takes no parameters, and we'll create also an object of the class penguin, which also takes no parameters. So we'll test the methods eagle info and eagle fly. Wait, penguin info, penguin and fly. Now let's test our program. Run. Yeah, we can see that we have I am an eagle, I am flying, and I am a penguin, and I am flying, which is not right. Penguin cannot fly. Okay.
So, here you can see that the subclass penguin cannot replace the superclass bird. The class bird has a method fly, and the penguin cannot use it, because penguins don't fly. So the Liskov substitution principle is broken. To solve this problem, I will propose a solution to the student. Create a class bird without a method fly. The class penguin will inherit from this class. Create another class flying bird, which inherit from the class bird, and has a method fly, and the class eagle will inherit from this class.
Okay, now we will implement the solution. So the class bird, the problem that we have is in the fly method. So we remove it, and we will remove all of this to avoid confusion. Okay, so now we will create another class called flying bird. Okay, flying bird, which will inherit from the class bird. Okay. So this class will have the method fly. Print I am flying. Okay, great. Now we will create the class eagle. So the class eagle must inherit from the class flying bird. Okay, so we'll add the method info here. Okay, print I am an eagle. Great. Okay, and other class class penguin will inherit from the class bird, because in the class bird we don't have a flying method, so we'll inherit from the class bird. Def info here, just print I am a penguin. Great. Now we will test the program if name equal to main. Okay, we will create an object eagle, which will with the eagle class. Okay, and we will create a penguin also. Okay, great. Now we test eagle. Eagle info, eagle fly, penguin. Penguin now has just one method, info. It has no method fly, so we cannot use it. And now the program seems right. Okay, so I am an eagle, I am flying, and I am a penguin. No method flying, because penguin cannot fly.
So, using this solution, we don't need to make changes in the superclass bird, to adjust it to the subclass penguin, and break the open-close principle. The class bird and flying bird can be also reused to create other bird subclasses. And you know now that we must be careful with the inheritance, even when superclasses and subclasses look very similar like the classes bird and penguin. If you like the video, please subscribe, and turn on the notifications bell. Thank you for watching, I see you soon.